Hello, today we'll talk about read-only memory or ROM. ROM is a memory which is not volatile, meaning that the data inside the memory is retained even when there is no power connected to the memory. This is an example of several ROM that is available. For example, this is BIOS, basic input output system in the computer. So meaning that when you turn on your computer, you need a certain system to boot up the computer and so on. So the data must be retained. And when you turn on the computer, it will start up the operating system and so on. So the data cannot be changed. So it is a permanent data and it can be maintained even if there is no power source. So the data is actually wired into the memory chip during the fabrication process. So in order to do this, you have to be sure what you want to put inside the memory before the fabrication can take place. So there is no room for error. This is an example of ROM of 8 words by 5 bit, 8 words, so meaning that you need 3 input lines to address all the 8 locations, and you have 5 bit at the output. And this is in general 2 to the power of n words by m bits, so you need m output over here, m bits. 2 to the power of n words, so you need n bit decoder. Decoder is to reduce the number of lines to address all the memory location. And usually ROM have 2 types of array. One is NOR base and another is NAND base. For the NOR base ROM, it uses a PMOS transistor at the pull up for the column line. Okay, and then you have a row line that is connected to NMOS transistor at the intersection of row and column lines. The presence of NMOS will indicate there is a logic 1 is stored. When there is no NMOS, meaning it is a 0 logic is stored. Okay, so if NMOS is present, it will pull down the column line to low, but if there is no NMOS, it is logic 1. Okay, so this is the example of NOR base. So if you look at line, this one, C4, column C4, there is no NMOS, so it is a logic 1. If there is NMOS, it is a logic 0 because it is pulled down to the ground. If you look at C1, 0010, so there is NMOS, it is pulled down to the ground. Similarly for this, there is no NMOS, it is logic 1 over here, and there is NMOS, so it is a logic 0. For NAND base, it uses a depletion load NMOS as the pull-up transistor, and all the column NMOS are connected in series. And unlike the NOR base, for NAND base, if there is NMOS exists in the column line and the row line, it means it is a logic 0 stored at that particular junction. If there is no NMOS, then the column line will remain high and it represents logic 1. Okay, so all the NMOS are in series in order to read from a row. Okay, so if you look over here, for example, I take this column 1, C1, so there is no NMOS, it is logic 0. If there is NMOS, it is logic 1. No NMOS, it is a logic 0. Okay, so this is the column line and this is the row line. So if you look over here, the behavior of NOR base and NAND base is opposite. When there is a NMOS present, for NOR it is logic 0, but for NAND is 1. and for there is no NMOS, for no it is a logic 1 and then is logic 0. This is example of ROM of forward by 6 bit forward, so you have a 4 blue line over here which is the word line, okay, and to indicate whether it is a logic 1 or logic 0, remember just now the dot when there is a NMOS it is a logic 1, when there is no NMOS it is a logic 0. So usually we'll represent this particular structure just with a dot. When there is NMOS, we put a dot over here, okay, right. Similarly for this, there is NMOS, so this dot over here. So usually we'll write in this way. For example, the word 0, it is a 0 1 0 1 0 1, the first one. For example, the last one for word 3, it is 1 0 1 0 1 0, so it is dot, no dot, there's a dot, no dot, and no, correspond to this, which is this line. This is just to simplify. Instead of drawing all this, we just indicate that by using this thing. This is the ROM array layout. So we have 4 lines just now, and this is for 1 unit cell, and this is the overall layout with the input and so on. And under ROM we have a programmable memory, and this is non-volatile, where the data can be written into it only once. The writing process is performed electrically, so meaning that we write the data, and this can be done after the fabrication. Okay, unlike the regular ROM, the ROM you must put the data during the fabrication, but for the programmable ROM, after the fabrication you can write what to be input or to store inside that thing, but you can write only once. Okay, so you need a special equipment to write the process, to write the data inside this, and it is very flexible and very convenient. This can be done because in 1984 Toshiba has invented a floating gate transistor. With floating gate transistor, the threshold of the transistor can be changed in order to have a logic 1 or logic 0. So we can either raise or lower the threshold, so meaning that there is an absent or present transistor connected to each particular junction. Okay, so this can be done by applying an electrical field through a special technology. Okay, this is all done after the fabrication. And under PROM we have what is called read mostly memory. Read mostly memory meaning that the read operation is more frequent than the write operation, and for this particular read mostly memory we have EEPROM, and flash memory. The EEPROM is erasable programmable, so meaning that after you have programmed the memory, you can erase that. So it is a read-write operation, unlike the PROM. EEPROM meaning that you can write, erase it, but for the PROM you just program it. Okay, so for EEPROM it is using electrical technology, to write the data inside the memory. This process or erasure process can be performed repeatedly, and the time taken is quite long. Okay, EEPROM is more expensive than PROM. The advantage is you can change the data inside that. Okay, so this is the floating gate just now. For the regular transistor, you don't have this. You only have one gate and outside, but for this you have gate, and in between a very thin gate outside, so the gate some sort of floating, this one. Okay, so with that you can lower the threshold and you can store the data inside this, and then you can erase it. And for the another type of ROM is EEPROM. This is electrically erasable programmable read-only memory. This one is you can write data without erasing the previous content inside it. Okay, so the time taken is less compared to the EEPROM. Okay, so it is having more advantages of having EEPROM rather than just EEPROM. Okay, however, it is more expensive, and again it is still using the floating gate over here. Okay, this is example of the EEPROM. And another programmable ROM is flash ROM. Okay, and before that, this is example of 8 megabit EEPROM. We have several pins. We have address pin, and then also we have the data pin. Okay, data can be read out, and then we have a power supply VCC and ground, which is VSS, and we have enable pin to enable the operation of the circuit, and then we have a program voltage VPP. This program voltage is used to write the data inside it. And for flash memory, it is intermediate between EEPROM and EEPROM, and the time taken is quite fast, so that's why it is called flash. Okay, and it is possible to erase just a block of memory rather than the entire chip. And like EEPROM, flash memory use only one transistor per bit, thus you can have a very high density. So this is example how to erase the data inside the flash, and this is how you program it. Okay, and this is example of NAND flash, okay, which is currently available commercially. It is one line. Okay, and we can have this example of commercial available NAND flash up to 64 gig, and then we can also have a no flash. This is the transistor with a floating gate, so this is the symbol for the floating gate. Okay, so this is the no flash structure, and this is the differences between NAND and no flash. No is quite slower compared to NAND, so that's why NAND flash is more available in the market. Okay, and for the no flash, it allow access to any address, which make it truly random access, unlike the NAND, because it is not really random access, because you have to read or write data in large block. Okay, thank you.